All right, so this is once again out of chapter 7.3, page 248, number 35 in this case. So this example is very, very similar to number 33, which you'll also find on the page here, or an example of. Now, anytime we see a proportion, hopefully you're thinking that we are going to, that's right, cross multiply. So I'm going to take the x plus 1 and multiply it times, or go across and multiply it times the x minus 6, x plus 1 times x minus 6. And then that is going to be equal to the other cross product. We take x minus 2 and multiply it times x plus 5. Now, to continue from here, we're going to need to simplify these. Now, for one of them, I'm going to go ahead and just FOIL it, as this is a method you're probably most familiar with. Again, FOIL, we're going first, outside, inside, last. First is x times x, which is just x squared. Outside, I'm going to take the outside term, so x and negative 6 in this case, so minus 6x. Inside, that's when we do 1 times x, or just positive x. And then last, 1 times negative 6, so minus 6. Now for this one, I'm going to do something a little bit different. Now I'm going to treat each of these as a side of a rectangle. So if I go ahead and do that, I'm going to say that, well, this one, if I go ahead and kind of make a generic rectangle here, I'm going to say if I want this side to be x minus 2, I can cut it into 2 sections and make this little piece right here x and this little piece right here minus 2. Now on the other side, I'm going to make the first section x and then the second x section positive 5. So if you notice, this side right here, we're going to have x minus 2, which is just our first term. On this side, we're going to have x plus 5, our second term. Now, hopefully you remember that a rectangle, to find the area of it, we multiply the length times the width. So if we find the area of this rectangle, then we can go ahead and know what x minus 2 times x plus 5 is. Now to do that, what we're going to go ahead and do is we're going to break this up into smaller rectangles. I'll show you what I mean. So what I can basically do, and we're going to do this over and over again, but just to show you with the first one, is I can kind of just cut off parts of this section and just look at a very specific part of this rectangle. Now if I do that, you can see very clearly this makes a very small rectangle. In fact, this one would be a square, but we have x times x, which is just going to be x squared. Okay, now if I move this over here, one thing we know about rectangles is that if this piece is x, then this piece right here would also have to be x. So if I cover this up, I can clearly see that this part right here is just 5x. Okay. Now if we continue that process, what we're going to find is that here, for this one here, we have a length of negative 2 and a width of x, so this is going to be negative 2x. And here we have a width of 5 and a length of negative 2, so this will just be negative 2 times 5, or negative 10. Now, you may or may not notice, but what we actually just did is FOIL, but we have this kind of graphic organizer that allows us to stay nice and organized pretty easily. Now we just take each one of them, and and we have x squared minus 2x plus 5x minus 10. Now we need to do some simplification. Now in this case, I'm just going to go ahead and underline any like terms that I see. I see that I have a negative 6 here and a positive x. And then on the other side, I can see that I have a negative 2x and a positive 5x. Now those are the only like terms that I see. So I'm going to go ahead and combine those together. Negative 6x plus x is just going to be negative 5x. X squared minus 5x minus 6. Just bringing down the other two terms, is equal to x squared. Well, if I go ahead and combine these like terms together, well, negative 2x plus 5x will leave me with 3 positive x's minus 10, bringing down that last term as well. Now, I notice that I have an x squared on both sides, so I can feel pretty confident that if I subtract this x squared from here and this x squared from here, they're just going to cancel out and make my overall equation much simpler. So we have minus 5x minus 6 is equal to 3x minus 10. Now you have a choice to make, and you can go about this a few different ways, but I notice that over here I have a nice positive 3x and I have a negative 3x over here. So I'm deciding that I'm going to go ahead and add 5x to both sides so that I can get all my x's on one side. That cancels them off this side, and then I'm left with just positive x's, which isn't terribly important, but it's helpful. So we have negative 6 left on this side. 3x plus 5x is 8x minus 10. Okay. Now I want to get everything else off of the side x is on. Do not divide that 8 first. You're going to end up with fractions. Make sure to add the 10 first to both sides. Okay, then we're left with 4 is equal to 8x. Okay, I'm going to rewrite that right over here. So we have 4 equals 8x. Divide by 8 on both sides, and we're left with 1/2. 4 over 8 is just 1/2 is equal to x. Those 8's cancel out. Oop, there goes my book. All right. And again, as usual, we could go ahead and plug this back into our original proportion, and you would see that this value of x does give us two ratios that are equivalent to each other, and therefore proportional.